Hey guys, welcome back. In this video, I'm going to be talking about collision detection. This is being able to detect when one graphic or one object is intersecting with another object. This is a primary scoring mechanism in most games. I'm going to show you the theory first, and then we're going to look at some code to make it happen. And we're also going to look at a really clever solution that Java provides. So let's get started. So we're going to look at the simplest example of two rectangles colliding with each other. It is possible to do collision detection with more complicated shapes, but the concepts are the same for all shapes, and this one is the easiest to implement. I'm just going to remind you that 0, 0, the origin, is in the top left corner for computer graphics, unlike down here in the bottom left, which you might be used to for the Cartesian plane. And I'm going to ask you to remember that when we're storing rectangles in memory, Java stores 4 bits of information about each rectangle. The top left corner, an x and y coordinate, and then the rectangle's height and the rectangle's width. And we've stored those for both rectangles here, and I'm referring to them as x1, y1, x2, y2 in my examples. So let's take a look at what a collision looks like. So here we see two rectangles colliding. One is overlapping the other. And we're going to look at what is going to be true about x1 and y1 and x2 and y2 in these kinds of situations. Here's another example of a collision where we've collided with it from the top. And here's yet a third example of a collision where we're completely inside the green rectangle. So in thinking about collisions, we're actually going to consider just 4 scenarios. All of the possible collisions that we might encounter with these two rectangles can be handled by just looking at these 4 scenarios. First is the top left quadrant, and then the top right quadrant, the bottom left quadrant, and the bottom right quadrant. Now you might be asking yourself, well, what if I don't collide in one of those corners, but I actually collide in the middle, or I am completely contained within the rectangle? You're going to find that those scenarios can be handled with just these 4 if we just adjust our comparison to include an equal sign that will handle the middle portions as well. So let's start breaking this down to consider what does it mean to collide. And I'm going to simplify the problem here by just looking at the x-coordinates and the different widths. So here I have removed all of the y-coordinates from both of my rectangles, and I'm just going to be looking at what happens when one rectangle overlaps the other vis-a-vis the x-coordinates. And you can see here that I have added the x1 plus width 1 corner. However, you should know that Java doesn't store that per se. You'll have to calculate it. Now, I'm going to be overlapping these rectangles, and I'm going to be looking at these 4 situations. How does x1 compare, x1 being the blue rectangle, to x2 and x2's width? I'll also be looking at the top right corner of each rectangle and doing a comparison there. So over here on the left, you can see that I have defined all of the possible situations. There's only 4 for the x-coordinates. And you can see in this default scenario, x1 is less than both the x2 and x2 plus width, and x1 plus width similarly so. Now, if you have trouble visualizing that, here I've overlaid a grid with some numbers on it so that you can see that this x1 coordinate, which is located around 300, that is definitely less than this x2 coordinate, which is somewhere around the 580 range, and 300 definitely less than 580, and the other corners as well. So here we have our first collision. And I've highlighted in red what has changed in our 4 conditions. x1 is still less than x2, and x1 is still less than x2 plus width 2. However, x1 plus its width is now inside the rectangle, and so that is this situation right here. x1 plus width is now greater than x2. But x1 plus width is still very much less than x2 plus width 2. Here's another possible collision where we have moved horizontally over a little bit, and now we're inside the rectangle. Again, I'm comparing just the x-coordinates, and I've highlighted in red the things that have changed. Moving over a little farther and just comparing the x-coordinates again, I've highlighted in red what has changed. Now the x1 plus width 1 is greater than both x2 and x2 plus its width 2. What I'm saying there is that this corner here is greater than this corner and this corner. x1 greater than x2, but x1 is not greater than x2 plus width 2. Finally, we've moved past the rectangle now. All of our x1 coordinates are greater than our x2 coordinates, and this is not a collision. And that's something that we need to consider in our code. Now, let's talk a little bit more about this first situation where x1 plus width 1 was greater than x2. It turns out that in all of our 3 examples, that was always true. And so that begs the question, is this enough? Is this all we need to consider when we are looking for collisions, since that always seems to be true as we move horizontally across this rectangle? And there is a scenario where this is still true, but we are not colliding with the rectangle. And I'll pause just a minute for you to consider how that might be so. And here's the answer. Here you can see that the corner x1 plus width 1 is still greater than the coordinate x2, looking along the horizontal axis. However, we're not colliding. So it's not enough to just look at these x-coordinates and conclude that there is a collision. We also have to consider the y-coordinates as well. So here I've set up the examples for the y-coordinates. I'm just looking at the y-coordinates, not the x component of them. Here is the default scenario where we are not colliding with the rectangle. We are slightly above it. And I just want to call attention to the fact that, again, 0, 0 is up here, and y increases as we go down the axis this way, which is the complete reversal of the Cartesian plane. It's something to get used to. So here, this statement y1 is less than y2 is true in graphics coordinates. y1 is up here. We're going to say this is somewhere around the 100, 200 range, and y2 is down here, probably in the 400 or 500 range. So y1 is still less than y2. All of these y coordinates up here are less than the y2 coordinates down here. Here's our first collision. Again, I've highlighted in red what has changed. You can see that y1 plus height 1 is now greater than y2. Here you can see that both y1 plus height 1 and y1 itself are greater than y2. And finally, you can see that now y1 plus its height is greater than y2 plus its height, y1 greater than y2, etc. Important to note that y1 is still less than y2 plus height 2. That has not changed. Finally, we move past the green rectangle here. Everything has changed. We are greater than all of the y2 coordinates, and that means that there is no collision. So let's go back to our 4 scenarios. So looking again at scenario 1, the collision in the top left corner, you can see over here on the left that I have now added x and y coordinates, and I'm considering all of them, and I've highlighted in red the things that are that have changed from the default where we are not colliding. Here's scenario 2. You can see that several more things have become true, and a few things have changed back to false. Here's scenario 3. And go ahead and pause this video if you need to make sure that all of my math is correct. And finally, here's scenario 4. Now, it is possible to write the if statements for scenarios 1, 2, 3, and 4 to detect a collision in one of those situations. However, that's a lot of code to write. That would be 8 conditionals for each if statement, and there would be 4 different if statements that you would have to write. But there's a simpler answer. It turns out, in all 4 scenarios, that some statements never changed. In other words, all 4 scenarios share some statements in common every time. And I'm going to show you now by highlighting the 4 statements that never change from scenario 1 to scenario 4. Here I have underlined and bolded the statements, the 4 statements that don't change. And I'll just go through those again. Note that some of the statements change from scenario 1, 2, 3, and 4, but these 4 do not. So here are the 4 statements that never changed, and it turns out that these are the only things we need to evaluate to determine if there is a collision. And here is what that might look like if we were to write Java code. So that's some of the theory behind collision detection. Now let's take a look at how we might use some of these ideas to write our program. Okay, so for this I created a new project. I called it Collision Demo. And this is sort of a stripped down version of our previous project where we were doing the mouse listener and the key listener. I've changed the title here, and I'm not using a button panel, I'm just using a drawing panel. You can see that here. Pretty much the rest of the code has not been changed. Looking over at the drawing panel, you can see that I am not implementing a mouse listener or a key listener. We're just going to be using an action listener to do the animation. I've taken away a lot of the imports, and you can see here a lot of the private fields have been removed. I'll just be using a timer. And then I've created 2 new objects, a green laser beam and a blue spaceship. So let's take a look at those 2 objects first. Here's green laser beam. You can see that it extends something called game object. I realized that both the laser beam and the spaceship were going to have an XY coordinate as well as a height and a width. And so rather than duplicate the code, I just went ahead and put that inside game object, which you can see right here. It has 4 fields, an X and Y location, a height and a width, and you can see that it's got private setters and getters, public setters and getters for those private fields. So both the blue spaceship and the green laser beam will share these attributes. So you can see here, green laser beam simply adds 1 more private field, a color, probably going to be green, yeah? And you can see here its constructor calls the superclasses constructor, that's game objects constructor. It's going to pass it the X and Y location that it was created with, as well as a width and a height. You can see here that I have set the color to a shade of green that I like, and IntelliJ helpfully is showing me that shade right here. All a green laser beam can really do is draw itself, and that will simply be setting the color to its current color and then also filling in a rectangle at the X and Y location and the width and the height. Blue spaceship, a little bit more complicated, but not by much, because I've added a health bar to blue spaceship. So that is right here. And then you can see it also has a color here in its constructor. I call the superclass again with the X, the Y, the width, and the height. I set our health bar to whatever health parameter I'm passed. And then finally I set the color of the blue spaceship, this time just to blue. The draw method for blue spaceship is a little more complicated than green laser beam, but again, not by much. My idea here is that if the health bar ever reaches 0, then we're going to simply display a message instead of drawing the spaceship. I'll Obviously, you can react to the health bar reaching 0 in different ways. You could subtract 1 from the player's score. You could set the game to be over, etc. This was just an idea I had to show you how we might integrate this in a real game. Here I've set the color again and done the fill rect just like we did with green laser beam. The setters and getters are down here. So returning now to drawing panel where a lot of the action is going to happen. Here in the constructor drawing panel, I go ahead and call the superclass constructor. I create my laser beam and my spaceship. Here are some coordinates that are going to work for me and display nicely. And then finally I set the timer and I start the timer so that we can go ahead and call action performed. All paint component does is it draws the two objects, and action performed right now, being called every quarter of a second, just tells the screen to repaint. So let's just go ahead and run this real quick. You can see what it looks like. Nothing too crazy. Everything looks like we expect. That green laser beam I plan to make travel into the blue spaceship. So let's do that now. We'll go into action performed, and we just need to move the laser beam. So every quarter of a second, we are going to change its X location. We will change it to its current location. So that's called to its, we have to specify the object name first, of course. We get its X location, and we are just going to add 10 to that. Let's go ahead and see what that might look like. And that looks as we expect. On to the collision detection. Okay, so here's the plan. After we have moved the laser, we need to check to see if we've collided with anything. So the first thing I'm going to do is what I call wishful programming. I wish that there was a method called check for collisions. Of course there isn't yet, but I will have IntelliJ go ahead and create that for me. Inside check for collisions, I am basically going to write that long if statement, and if it's true, I'm going to go ahead and set a Boolean variable to true, saying that we are colliding. So let's go ahead and go get that code. So now we've pasted the code into our project, and we're going to go ahead and adapt it to our needs. This, of course, the blue was the ship that we created, and we will need to access its getter. So I'll be getting the X location. And the green is our laser. I will go ahead and access its getter as well. And this also was our laser, and this time we need to get the width. I'm going to go ahead and fill in the rest. All the blues become the ship, and all the greens become the laser. And finally, green is the laser. And I will get the Y location. Okay, so there's our if statement. Now we're going to go ahead and say we are colliding set to true. Now this is a Boolean variable that I haven't created yet, so I'll go ahead and scroll up here to our field, and I'm going to create that Boolean. We are colliding. Oh, it needs to be a Boolean. I need to set that up. Great, we are colliding. Inside my constructor, I want to initialize that variable to false. And down here, we're going to say we are colliding is true. Now, if we are not colliding, then I do want to make sure, and this is important, that I set we are colliding equal to false. Otherwise, if you forget to do this, the first time you collide with something, you will be colliding forever, even when you have moved off of the particular object. The last step is to go into our paint component And now we are simply going to say, well, if we are colliding, we're just going to go ahead and give ourselves a little message here, g.drawString. I will go ahead and say in bright bold letters, collision detected. And we will put this, let's see, our ship is 200 over. Let's say it's going to be at 300, and we're about 100 and 200 down. So we'll go ahead and say at location 300, 400. And if we are not colliding, then we will give ourselves a message saying all is well. And you know what, let's go ahead and add ourselves a little bit of color. Red, of course, for the collision. A lot of typos today. And black if all is well. There we go. So, to recap, we wrote an if statement to check to see if we are colliding. If so, we set a Boolean variable equal to true. Remember, check for collisions is being called by action performed after we move the laser. That's important. And then finally, we react to that up here in ping component. If we are colliding, then we go ahead and write a message as such. Let's go ahead and run this and see what it looks like. So you can see all is well until the bullet enters the ship, and then you can see that collision is detected, and then when we leave, all is well again. Now I'd like to show you how we could use one of Java's built-in classes to do collision detection in a much cleaner way. So Java has a lot of simple but powerful classes built into it, and one of these is the rectangle class. The rectangle class contains a simple method called intersects that returns true if one rectangle intersects with another rectangle. Now, in order to implement this, we are going to have to modify our game object to include a method, which I'm going to call getHitbox, that will simply return a rectangle that describes the current game object. So here we go. Go ahead and import that class. And all this will do is return a new rectangle, which is specified by 4 things. First, the X, then the Y, then the width, and finally the height. And that's all we need to do inside of GameObject. Remember that both blue spaceship and the green laser beam are game objects, so they have access to this method. Back here in Drawing Panel, instead of writing all of this crazy if statement, we are simply going to create 2 new rectangles. The first is going to be the ship's hitbox. And we will call ship.getHitbox. That creates 1 rectangle. Second rectangle is the laser's hitbox. And now, instead of writing this long if statement, we can simply say that if the ship's hitbox intersects with the laser hitbox, we will say that a collision has occurred. Look how clean this code now looks. We'll go ahead and run this. And it works just like before. However, the code is a lot nicer and a lot cleaner. Now, this intersects method inside of Rectangle is not magic. It contains an if statement, much like the one that we just wrote. Well, there's a lot to collision detection. I hope you found this discussion helpful, and don't forget to like and subscribe.